Dictionary with the map. And but however, what we've learned so far, the modeling is actually, this is not what I wanted to do. I just wanted to do it this way. The modeling power that we have right now is not all that sophisticated. There we go. So object-oriented programming gives us some new tools for modeling things. So let's take, for instance, a dog. So, and a cat, and a bear, and a great ape, and people. All of those organisms have certain common traits, yes? For instance, we are all mammals. Mammals have everything that lives under the heading mammal has certain common traits. So with object-oriented programming and polymorphism, you can create relationships that you can't create without it, and the relationship would be is-a. Appropriately spelled in modern times I-Z-Z-A, because if it's not misspelled, it can't be cool. And that's opposed to has, like can has cheeseburger. Or is that too old at this point? Right? That's like so last decade. So far everything you've done is a has-a. So a node has a frequency. Node has a vector of integers. So you haven't seen how to represent the is-a. So for example, a dog is a mammal. So we can create a certain model of mammalness, but then derive from it the differences that make the dog a dog rather than a generic mammal. So take a look on screen. You'll see that I have a class called mammal, and it's no constructor, don't need one for this demo. And by the way, this is just a demo. This is to give you, we're not really gonna, we're not studying this in depth right now. It's just a taste so that chapter 10.1 makes a little more sense. Okay, so sit back and enjoy. The idea is that we've created a class called mammal, and the mammal makes noise. So if I call mammal, an instance of a mammal, let's say m.speak, I get back a string of mammal noise. Okay? So here's some new syntax. There. So dog, public mammal. So this is saying that a dog is a mammal. The word public says that everything that was public in mammal should still be public. Okay? So dogs make sound. So one would presume that this speak method should be more specialized to dogs than the generic mammal speak method. And that's part of the idea of the polymorphism, but specifically this is an example of inheritance. So actually there's no inheritance here, so forget that. I was getting ahead of myself. So let's take a look at the mammal speak, generic mammal noises. And the dog goes woof. All right, so here's something cool. Now, you know that C++ is strongly typed, and you've probably gotten lots of warnings in your time about something being an incompatible type. It's because C++ is a strongly typed language. But look at this. I have a vector of pointers to mammals. And I'm going to declare dynamically a mammal and put it on the vector. but I'm going to declare dynamically a dog and put it on the same vector. Now you might think that's incompatible types, that you can't put one type of thing. You can't put int on a vector of node, right? Just wouldn't work. However, this does work because a dog is a mammal. Got that is-a relationship? So now I'm going to say, I'm going to ask the mammal, that's at location 0, I'm going to ask the location 0, the mammal to speak, and I'm going to ask the dog to speak. So let's see what happens. Compile it and run it. And that's not what I wanted because I didn't save the program. So let's run it again, compile it again. And look at that. I'm getting generic mammal sound twice. I'm not getting the woof. And the reason for that is I'm getting to the dog through a vector of pointers to mammals. So which speak was called? The mammals speak. But if I add another keyword to the base class, namely mammal, dog is derived from mammal. I'm going to add the keyword virtual here. That's the only change I've made. Let me recompile and run it. And now I have the dog goes woof. So this is the example of polymorphism. Many shapes. Right? What's going on is by adding the keyword virtual to the base class, it means that the derived classes the methods there should override and hide the methods of the base class. So that even if I access the dog through a mammal pointer, the compiler is smart enough to figure out that the mammal pointer this time refers to a dog and it calls the right thing. Okay? So that's just a taste. Let's move on. It's going to be the subject of chapter 10.1, which is due the Monday you come back. Okay? It's just one chapter. I'm not being mean. Well, you know, that's up to you to decide if I'm being mean or not. But okay. Where is PowerPoint? Okay. So this talk is, I've been giving versions of this talk for probably 10 years or more. And, you know, I kid you when I say, you know, it's life-changing. Well, actually, I'm not really kidding you because students have come back after a number of years and said their lives were changed by this talk. So I guess I can legitimately say it's a life-changing talk. You know, like people tell me, so therefore it's a fact, because that's the way things are now. If people tell you something, it must be a fact. Okay, so the idea of this talk is it's divided into two parts. There's the discourses, so I'm going to pontificate for a while, and then there are dialogues. The dialogues are all true. Every one of the dialogues took place in previous classes. So keep that in mind as we go through them. Okay, so the idea, and actually this is misnamed, it shouldn't say summary. So Megan and Fredo wrote buggy code. Everybody writes buggy code. We all write buggy code. Later today when I start coding, because I like to code every day, I'm going to write buggy code. It's nothing to be ashamed of. It's part of life. It's part of the process. And at the end of the talk, I'll make the case that you should embrace it as part of your craft. Like if you embrace winter, then winter doesn't suck. Okay? So if you embrace debugging, then debugging doesn't suck. So Megan paid attention to the lessons in this talk and solved her problems quickly and went out dancing. Fredo is still slamming Red Bulls, and he can't feel his lips, so don't be like Fredo. Okay? Okay. So a lot of people say that debugging is an art. Well, how are you going to teach art? You know, either you get it or you don't get it. Well, I did the following in the previous class, so why don't I do it in this class too? I'm going to look right at the lens and I'm going to say that's bullshit. Okay? The thesis of this talk is that debugging is based on science, and you know, if we can't teach science, well, then this is being at college is kind of a useless endeavor. So science can be taught. All right, so this algorithm is, you start at the top, you notice that the program doesn't work, so you make a change. Does the program work? If no, make a change. If no, make a change. If no, make a change. Okay, this is the typical debugging technique or algorithm used by beginning students. So this is you, if you do that. Okay? And in fact, the argument can be made that it's even worse than being on a hamster wheel, because every time you make a change for no good purpose, you risk damaging the hamster wheel even more. So it's worse than this. Okay? So instead, debugging can be placed on a rigorous basis if you apply this version of the scientific method. The first step is to observe and gather data. I claim that bugs want to be found, and bugs give you all sorts of information about how to solve them if you only paid attention. If only you paid attention. Okay? I can tell I'm getting old, because at this part of the talk, I usually dance around saying, I'm here, the bug is here. But at this point, you know, just blah, blah, blah. Okay, so observe, gather all the information you can. Then, formulate the hypothesis. What would explain what you're observing? Okay, without the hypothesis, you have no reason to assume that whatever change you make has any chance of working. So you got to formulate the hypothesis and then test the hypothesis. So you have to think of the hypothesis and then what specific change can you make that will test that hypothesis. And thereby, you are approaching the problem as in a methodical way, and I'll get to, I was thinking I was going to the next slide. I should pay attention to the computer. So my first pontification, the oracle says, a fix isn't a fix until you understand why it's a fix. Okay, because you may make a change and the bug seems to go away, but you have no idea why. And if that's you, if that's what happened, then you haven't fixed the problem. You've masked the problem. Problem's still there, probably, and it's just going to bite you on the butt some other day, or in some other way that's even more serious than now. God forbid it goes out into the field. Okay? Maxim. This is where I thought I was a moment ago. If you make a change, so you're testing the hypothesis, if you make a change and you don't observe a benefit, then remove the change. Otherwise, you're on the hamster wheel. You're chasing your tail. You're moving the goalposts, etc., etc. So you make a change in order to test the hypothesis. If it doesn't give you a benefit, then remove it. Okay? Now, this little footnote here that says, unless you are absolutely certain you're fixing a different bug, I don't know about you, but many times I'm hunting for this bug, and while I'm doing that, I observe something over here, and I have to say to myself, how the hell would this ever work with that over there? and I can make a fix to that, and of course test that, right? And then return to this bug over here. All right. I should put I did put my initials on it because, like making memes is like the highest form of expression now. So, and the cool kids don't say memes. What do the cool kids say? No? Nobody here is cool? Okay, so this is an example of meme. Okay, so this is a crash. Okay, if you're looking for the bug, it's some number of hundreds of yards back. Okay, what you're seeing here is the result of a bug, the end result. At some moment backwards in time, the locomotive began to leave the tracks. That's the bug. Okay, that's what you want to find. Okay? Now, Mickey Cohen was a high school teacher of mine. He was talking about surf clams as a marine biologist. So, you're walking along a beach and you see a little hole and you realize that's a surf clam. Well, chances are there's dozens or hundreds of surf clams beneath the sand. Okay, so when you are observing a crash, you have to be mindful of the fact that there's probably a series of unfortunate events that led to the crash, but one of them was first. Okay? So in looking for this bug, you may actually find a bunch of them. Where there's one, there's many. All right, so here's the point again. Bugs want to be found. They are announcing themselves. This is the part of observing and gathering data. Okay? You have a bug, don't make a change reflexively in a knee-jerk manner. Instead, take a deep breath and take a moment to observe. Gather data. What can you learn about the manifestation of this bug? Okay. Conan Doyle's Law. This is the definitive Sherlock Holmes, those crap movies that they have recently about Sherlock Holmes. They are total crap. The idea here comes from the Sign of Four, written in 1890. When you have eliminated the impossible, whatever remains, however improbable, must be the truth. What is this talking about? It's talking specifically about assumptions. Have you ever said to yourself, the bug can't be here? Okay? That is an assumption. When it can't be here, and it can't be here, and it can't be here, and it can't be there, pretty soon it can't be anywhere in your program. Well, clearly an assumption you're making is not correct. So fairly quickly you should be aware that you may have to test assumptions that you thought were absolutely true. Okay? Write a little, test a little, write a little, test a little, write a little, test a little. Say it with me. Write a little, test a little. Okay? Okay. Because this is the process of building software. And this is what happens when you write software that you are uncertain about the quality of the lower levels of your software. So you proceed to the first story only when your foundation is solid. Okay, you proceed to the second story only when you are sure the first story is solid. Okay, so write only enough code to get to the next test. Okay? If you write a lot of code without testing, you're simply making the job of finding the needle in the haystack harder because you're making the haystack bigger. Okay? All right, always play defense. there is this notion of defensive programming, which I have already begun instilling in you, but I haven't articulated that it was defensive programming. So in Project 1, Project 2, you are using argv, correct? And I have told you that you must check argc before you go deal with argv sub 1. Let's say you didn't check argc to make sure that argv sub 1 is valid. You would, in fact, be dereferencing a null pointer leading to a crash. Well, this act of checking argc, that's defensive programming. So you added a little bit of code. In this case, what? A couple of lines, 3 lines max? Depending upon your indentation, 4 lines? Whatever. That was extra code that, you could say, that doesn't help me finish my program. I don't need to write that. I don't want to waste time on that. Yet, if you consider the time spent putting in the defensive code versus the time spent potentially debugging, you find that putting in the extra work comes to an end. Debugging may never come to an end. Okay? Always play defense. Okay? Don't play defense. It's like, okay. Okay, so let's move on to the dialogues. And this whole format of this talk was motivated by this film because, what's his name? That's Shifu, right? Yeah. And this is who? Po? Okay, so Po does something stupid and Shifu just wants to slap him, right? Okay, so the whole idea of this talk derived from that. And, I don't know, these silly laws say I can't slap you. But as you get to know me, you'll know that I'm kidding. If I ever say to you, lean closer so I can slap you, all right? So I really don't mean it, but I'm talking about this talk. Okay. Again, all of these dialogues happened. So the idea of not understanding the fix, my code crashed, I added a printout, now it doesn't crash, so it's fixed, right? No, it's not fixed. Is the bug still there? Yes, it is. And now that you're using pointers and dynamically allocated memory, from here on in is where you're going to find bugs like this. This is called a Heisenbug. Anybody get the joke? Okay, so what's the joke? Heisenberg's uncertainty principle. The idea is that if you observe something, you're changing it. Okay, so this bug goes away when you look for it, and it comes back when you don't look for it. It's just like Major Major from Catch-22. Anybody read that? You got to read it. It's a great book, right? So in there's a character named Major Major who is supposed to be listening to the problems of the people in the unit. And he tells his assistant that you can tell people that they can only see me when I'm not here. Okay, if I'm here, they can't see me. All right? So, same thing. I love this one. This is especially true when you're using an IDE where it flashes a big dialogue and you hit OK to get to the debugging. So what's the error say? I don't know. I didn't read it. Okay. So what does this violate? This violates that first point in the scientific method. So this is you, right? You're just clicking things, hoping something will get better. Instead, you have to take the time to read all the error messages, to observe all of the things that the bug can tell you. Okay? Only in that way will you be able to make an informed hypothesis. Okay? Oh, this is good. My code crashes, and I look over your shoulder, and the student says, I say, you have warnings here. And the student says, yeah, but they're just warnings. Okay, so follow me here. Warnings literally have the word warning in them. That sounds serious. It is. Okay? Now, I haven't graded one of your assignments yet. I am about to. If you generate a single warning, I will take 10 points off your grade, just like that. Okay? Just a single warning and you're docked 10%. Okay? Why? Why am I being such a hard, you know what? Because of this. This slide right here. Warnings are to be taken seriously. Okay? Bugs want to be found. Say it again. Bugs want to be found. The warning may be pointing at the bug. You got to pay attention. So we've started to learn about memory leaks. So the program runs for a while and then it crashes. There's something wrong with my computer, right? No. A reasonable thing to think about is, do you have a memory leak? And now you know what it is. You won't give an answer like that. This answer was in fact given. Okay, all of these dialogues are true. They all actually happened. And that was my reaction. Okay. So memory leaks are bad news, especially in the world going forward. Software controls everything. I keep telling you about the pacemaker I might need someday, and I don't want to die. Okay? Seriously. Valgrind is a tool that you know how to use now that is designed specifically to find memory leaks. Okay? Okay. My program stops responding to me after a while. So, well, a reasonable thing to think about is an infinite loop. No, I use while loops, not infinite loops. So, infinite loops are bad. One of your first signs of an infinite loop is your program stops responding to you. Infinite loops are such a big deal that Apple's first headquarters, the big one in California, not first headquarters, but the big one in California, the address is 1 infinite loop. Okay? This will happen to you. Not can, will. Again, you're just shaking your head. Okay? Bugs want to be found. The sign that, you want a sign that you have an infinite loop, the program stops responding to you. Okay, there's also, maybe it keeps outputting the same thing over and over and over again, and it won't stop. There's your sign. Okay? My code works great, except on this input. Did you try a test with just that input? Another thing, did you try single-stepping in the debugger? We haven't covered the debugger nearly enough, so we're going to do that in the future. The debugger is your friend. Learn how to use the debugger. Okay? There are a whole bunch of other techniques. Because we're short on time, I won't go into them. But sometimes, I'll give you a hint, sometimes the input that you crash on might be the 9,303rd piece of input you give it. So there are techniques to narrow down, you're not going to single step your entire program 936, whatever I said, times. Okay? So there are techniques to narrow it down. Yeah. Okay, the debugger is your friend. Use it. I looked everywhere. Guess which maxim this is? I looked everywhere. Did you look here? No, it can't possibly be there. Which one is this going to be? Okay, Conan Doyle's Law. If you've gone through all the impossible, whatever remains, no matter how improbable, must be the truth. So if it can't be here, and it can't be there, and it can't be there, it can't be anywhere in your program, clearly there's an assumption that you've made that's wrong. So you have to test your assumptions. And you might narrow down which assumptions to check using the following question. What would explain this bug if everything is correct? Well, if this went wrong, it would do that. Okay, let me go look there. Okay? Now you can't do that without this observation and formulation of a hypothesis. Okay? Defensive programming. Let me introduce you to my little friend assert. Okay? Assert is an include. You can include cassert. And assert will live in your code when you're using a debug build. So far, all of the projects you've ever written here have been in debug mode. Okay, there's an alternative to that called release mode. The difference is in debug mode, the compiler has inserted different various kinds of instrumentation to help you locate bugs. For one thing, it's made it compatible with the debugger. It's embedded information that the debugger uses to help you find bugs. Release mode has none of that. Release mode is designed to produce a program which perhaps is small as possible, and certainly as fast as possible. Okay, so assert is present only in debug mode, and in assert there is the way that it's used is a Boolean expression goes here. So the Boolean expression is you are asserting something that you know to be true. So for example, if I get here, the variable, the pointer that I'm using as a parameter, the pointer must be valid. So you put the assert in, and the assert, every time you run the program, all the time that the program is running, as long as it's debug build, it's going to be watching for you. And as this says here, it can stop the locomotive from leaving the tracks in the first place. What happens if an assertion fails is the debugger trips and stops you right then and there on the right line where the assertion was and failed. Okay. Okay. Maybe you had too much coffee and you wrote 5,000 lines last night and it doesn't work. And you go to the instructor and you say, why doesn't my 5,000 lines of new code work? And the instructor goes, Okay. So what did you do? You made the haystack really, really, really big. So what's this an example of? Write a little, test a little. Write a little, test a little. Write a little, test a little. Code in small units. Test in small units. Okay? Now, if you think it's impossible to write 5,000 lines last night, it may happen to you. Sometimes coding is like food poisoning, and it just has to come out. Okay? It's not pleasant. All right. We have not been grading you yet on your comments. Comments are critically important. If you do this, I will take points off your program. Okay? Because anybody who knows what I++ means knows that you incremented I. Okay? So rather than comment your code, you should comment, yeah, there you go. Duh! You should comment your thinking, not your code. Okay? Because coding, when you're doing it right, can feel like a meditation. And should any interruption occur, like being asked to feed the cat or take out the trash, your meditation is broken, You want to get back into that meditative state as fast as possible. Your comments, if you're commenting your thinking, helps you get inside your head again to that place where you were in the zone. Okay? Hey, you know, the next person to read your code might be you. So take pity on yourself. It doesn't happen here in school because, you know, I know what the deal is. As soon as the project's done, you're never going to look at it again. So once you get out into the real world, it's not going to be true anymore. You're going to be responsible for your code as long as you work at that company. So how do you get back into your own head? What were you thinking about 6 months ago? It's your comments. Okay? All right, my code doesn't work. And I look over the shoulder and say, there's no way it ever would work. Did you test it before you wrote it? Duh. What do you mean, test it before you wrote it? The idea here is write the comments before you write the code. If you're commenting your thinking, think out the process before you write the code. Okay? Don't get down the rabbit hole of dozens of hours of writing code and debugging code only to find out it was never going to work because you made a flawed assumption about the data structure or a flawed assumption about the algorithm. So if you write your comments first, it's like an opportunity to hear yourself think. It's like an opportunity to critically work through your own thoughts. And once you have vetted your thoughts, writing the code's easy. It's the thinking of stuff that's hard. My code doesn't work. What does the variable I need sleep do? I don't know. I was tired. Okay, this has actually happened. I have also seen variable names which are a dozen expletives combined. And I say, what does that do? And you get a different answer, but it's similar in nature. Okay. All right, look. Descriptive variable names really help. Okay. Now, I'm guilty as an instructor. All CS instructors use like I all the time. What the hell does I do? You know, I really should use, let's say, index if I'm indexing through something, or loop counter if I'm looping through something. Okay, typing is guaranteed to end. Debugging is not guaranteed to end. Besides, today's IDEs, the editors, if you type a few characters, they'll offer to fill in the rest. So it's not like you're going to get carpal tunnel because you used a long variable name. Okay? Get carpal tunnel because you wrote 5,000 lines last night. Another defensive programming example, this is legal to put multiple statements, notice the semicolons, multiple statements on one line. Human beings typically pay attention to the first thing and the last thing. So when you're reading your code looking for the bug, you'll very often miss the one in the middle. So don't do this. You know why? Because new lines are free. So use them. Don't do that. Oh, okay. I went too far. Okay, this is perfectly legal code if you put in the variable names and the types are right. But the only person who would write this begins with an A and ends in whole. Okay, you're just trying to impress your coworkers. Now, I'll tell you right now, the reaction from your coworkers will be, boy, what it begins with A and ends in whole. Okay. All right. So Some of the problems here is, first of all, that's really hard to figure out what it does. But imagine, even worse still, imagine that the same variable here, the assignment, also appears someplace else here, like over there. So this means this is the ternary operator, which is kind of a specialized if statement. So that means some of the time the variable will change, some of the time it won't, because that's what's called a side effect. A side effect of executing this are changes somewhere to variables that isn't really obvious. And you're especially vulnerable to side effects when you have the same variable on both sides of the equal sign. So watch out for that. One more point about this is you thought you were so smart. Well, you know what? A code optimizer is going to do it better than you anyway. So don't do that. Okay? It just makes it easier to have bugs. Okay. So here's some more information about assert. This is in the days of C. You can now simply say C assert with no .h. So the idea is you're asserting. It's like making a contract. I'm asserting that something I know to be true. And as long as the assert is active, when you're in debug mode, in other words, as long as the assert is active, the assert will check to make sure what you assume to be true is true. Okay? It's your friend. Get used to it. Another debugging technique, defensive programming technique. The bug can't be here because I copied it from over there and it works over there. And you look at it and you say, yeah, but over there it's different. I say, oh yeah, I made a change. So the point being is that if you find yourself pasting code, copy-paste, chances are very high that you should be making a function out of that code. Let's say you've pasted something 10 times in a larger program. You find a bug and you fix it 9 times. You forgot about the 10th. You still have the bug. Okay? So if you make a function out of it, you can call it 10 times. And if you've coded it once, and you fixed it, tested it once, and you fixed it once. Okay? All right. So the variable has to be one of these values, and if it isn't, well, it's not possible. Okay? Well, yet you have a bug. Is it possible that your impossible condition would explain the bug? If so, your assumption that it was impossible was incorrect. It's inconceivable! Okay? And that's your code. Okay. So the idea here on this slide is on a switch statement. A switch statement, you're saying it has to be one of these values. And you didn't code the default condition. So by not including the default, you'll never know if the value that you're switching on was not one of those that you made a case for. So always code the default case, if only to give you some type of error message that there was a case that wasn't handled. Okay? Same thing is true for if statements, especially if-else. So if this, else if this, else if this. Well, what if it's none of those? Then you fall through. Now maybe that's the right thing to do, but maybe it's the wrong thing to do. So you put that, I'm admonishing you to put in that impossible else at the end, if only to print an error message saying, here's a case you didn't handle. The blue screen of that. Yeah. Hey, by the way, what I just said, notice I use the same words for if, else, and switch. Somehow they must be related. Okay? Okay, let me tell you a story about a colleague named Ben Liblet. Before Ben went back to school for his doctorate, he was in industry. He worked for a company that will remain nameless, but they basically make all the chips in most phones. And there was a code review. That's when a programmer stands up and they defend their code facing the criticism of their colleagues, and assuming that the group mind will make constructive criticism. And there was this loop. It was the innermost loop of, and it runs billions of times, over and over and over again, billions of times. And Mary says, you know, if this and this went wrong, this would, you know, blow up in our faces. And Bob says, oh, you're crazy, it'll never happen. And besides, if it did happen, it'll be so rare. This loop is executed so often, we don't have time for an if statement, et cetera, et cetera. Bob is one of those, you know, loud people. And loud people generally win arguments. It's unfortunate, but true. So they agreed that they would do it Bob's way. 6 months later, a trouble report, a bug report comes in from tech support. It's been elevated to the engineers. So first it goes to tech support, then it goes up to the programmers if tech support can't make heads or tails of it. The error message was the following: tell Bob Mary was right. That was the error message. So after everybody went home one night, Mary put the check in, and she was right. Okay? My code doesn't work. Oh, look, you're not checking the return values. Oh, really? It has a return value? So why should I check that? This is you. Okay, no, this is me wanting to be with you. Okay, but by law, I can't do that. But I can think it. You'll never know if I was thinking it. Of course, I'm kidding. Of course, I'm kidding. So the idea is this. Oh, you know what? Let me say this instead. You're already doing this. You remember I've been admonishing you to check that the file is open after you opened it? After you think you opened it? That's this. You're checking the return value. Okay? Your program would not function at all if the file wasn't actually open. So you're verifying that it was open. You're checking the return value of the open. So you already know this. Okay? Okay, this one is, it's not for here. Let's move. Okay, Andy Warhol. Famous artist, draws Marilyn Monroe and Campbell Soup. And this is a quote from him. He said, dying is the most embarrassing thing that can ever happen to you because someone else has got to take care of all your details. This is in the talk because if your code notices a fatal condition, don't just crap out. Don't just crash. If you have the code to notice something really, really bad happened, which is a good idea, then take steps to clean up after yourself so that you're not leaving a database corrupted or a file corrupted or some other condition which has, will cause you embarrassment after your program's death. Okay? So if you notice something fatal, then try to clean up. Okay, one more dialogue and then one more slide. Student says, I crash every time I get here. Well, student, that is the best possible bug you can have. If it reliably crashes, that means you can reliably repeat it, which means you're absolutely going to find it. So that's good news if it crashes every time you get to a certain spot. Okay. So some final thoughts. Hey, we all write bugs. There's nothing to be ashamed of. If you allow that to deeply frustrate you, you will remain a deeply frustrated practitioner. Okay? I have heard people say, God damn it, I'm never going to use a computer again. I'm going to be a farmer. Okay? In fact, we even have a Facebook page, secret Facebook page from the operating systems class named something like Farmers United. And it's about frustrating operating system bugs with memes, or should I say meme. Okay? So grow your craft and take pride in your work. Embrace debugging as part of the process, and you may even find it as much fun as I do. I love debugging, not to say I make bugs on purpose, but when I have one, the harder it is to find, the more pleasure I take in finding it. Okay? It's a challenge. It's a puzzle. One of the reasons you're in this class is because you like solving puzzles. Well, your bugs are big puzzles. So try to enjoy it. And I keep saying something like this more and more. Software does run the world. So code, like it means the difference between life and death, because it might. Okay? I'm not being morbid, and I'm not being Debbie Downer. Seriously, you don't want to be the person responsible for downing an aircraft liner because you had a off by one error. Oops, sorry, you died. Okay, well, I didn't go to class that day, so you're all dead. Okay, don't be that person. Code like life depends on it. Okay. We did it in time. You have any questions? Okay, I put this online. So on the Carthage Computer Science Facebook page, you'll find a link to this slide deck. And of course, online, you'll have 2 versions of the video. I think this one went better than the first one, but don't tell the other class. Okay, any questions? Garrett?
What about some of the more mechanical aspects of debugging? Like how to put breakpoints and how to run it, how to step through it?
We need to cover that. By golly, by gum. We need to cover that, and we will. Okay? So just like nobody teaches you to debug, almost nobody teaches you how to use a debugger. So I've been telling you how important the debugger is. It's worth having a lesson on that. So we should do that. Okay, any other questions? Okay, have a great break. You do have a homework assignment due when you come back. It's reading one chapter, chapter 10.1. You also have a program due on Monday, which is during your break, okay? And thank you everybody for coming to the barbecue. I was blown away a second week in a row because when I left the barbecue, the room was still packed. Yeah.
What should we do about the check bash thing that's part of the spec? Is that on our end something we should be doing?
It's helpful to you. Right. So if you put in a word that shows up 3,000 times, certainly you're not going to check that by hand to see if it's the right answer. So that's what check bash is for.
Is it like something we add to our code, or is it a separate?
No, when you're on the command line, you'd say bash space check.bash space and give it a word. It'll produce one number, and that should be the same number as your frequency for that word.
Okay.
Okay? Have a great break, everybody.
I wasn't putting the first batch in the track, so I was just using